Hello everyone. In this video, we're going to be doing another AP type problem. Okay, so this is from the 2005 exam. As you can see, it's question number 2. So let's read this question. The tide removes sand from Sandy Point Beach at a rate modeled by the function r, given by r of t equals 2 plus 5 times the sine of 4 pi t over 25. A pumping station adds sand to the beach at a rate modeled by the function s, given by s of t equals 15t over 1 plus 3t. Both r of t and s of t have units of cubic yards per hour, and t is measured in hours for zeros less than t's less than 6. At time t equals 0, the beach contains 2,500 cubic yards of sand. Okay, so Part A, how much sand will the tide remove from the beach during the 6-hour period? So it removes at a rate modeled by r. So the total amount, okay, the total amount of sand you could find using an integral, okay? So the total amount will be the integral from 0 to 6, okay? You're starting at t equals 0 to t equals 6, and we're only talking about the sand being removed, so we only have to factor in r of t. So 2 plus 5 sine of 4 pi t over 25 dt. And what does that get us? Well, I could take out a calculator, okay, if you have a calculator, and you get... So what we're going to have to do is evaluate the integral of 2 plus 5 sine of 4 pi t over 25 with respect to t from 0 to 6. What do we get? Okay, so we get 31.8159. So what are our units? Okay, what are our units? Oops. So both r of t and s of t have units of cubic yards per hour. Okay, so that's our rate. So time is measured in hours and cubic yards is the amount of sand. So this has to be in cubic yards. Part B. Write an expression for y of t, the total number of cubic yards of sand on the beach at time t. Okay, so y of t equals, well, at time t equals 0, the beach contains 2,500 cubic yards of sand. So we know that y of 0 equals 2,500. So you could write 2,500, and you could write it as an integral. Okay, you can write this as an integral. So 2,500. So 2,500 plus the integral. Now we have to factor in both r of t and s of t, since both of those rates will affect the total number of cubic yards of sand on the beach. Now r of t, we're removing sand, so r of t will be negative, okay? So our total rate, if we can say y prime of t, that would be the total amount, the rate at which sand is being added minus the rate at which sand is being removed. Okay? So it's basically s of t minus r of t. R of t dt from 0 to t. Okay? And if you expand it out, you get 15 over plus 3t minus 2 plus phi sine of 4 pi t over 25 dt. So either of these expressions will work. Okay, so let's go to part C. Find the rate at which the total amount of sand on the beach is changing at time t equals 4. Okay, so what we can do is use our expression we got over here, y prime of t equals s of t minus r of t. Okay, so y prime of 4 will be 15 times 4 over 1 plus 3 times 4 minus 2 plus 5 sine of 4 pi times 4 over 25. And what do we get as a result? Okay, what do we get as a result? We get 15 times 4 over, so we get we have 4 points, so we have to subtract the rate at which sand is being removed, okay, because it's removing, it's decreasing the amount of sand there. So we have 2 minus 2 plus 5 sine of 16 pi over 25. Okay, so we have negative 1.9088 cubic yards per hour. Okay, which means that the number of the total amount of sand is decreasing by 1.9088 cubic yards an hour at time t equals 4. Let's go to part B. For zeros less than t is less than 6, at what time t is the amount of sand on the beach a minimum? What is the minimum value? Okay? So we need to find the absolute minimum on this interval, okay? Because we're given a closed interval. So what we need to do, okay, is set the derivative equal to 0. So we want to set y prime of t equal to 0. So we want to solve this equation. Okay, and what do we get? So let's do solve. So 15t divided by plus 3t. Okay, so what do we get? So it's trying to solve the equation, the calculator. It's taking a long time. Okay, so we get a potential time t equals 5.1179. Okay, so what we need to do is test all these values. Okay, so we want to find, so y of 0 is 2500. They give us that. What's y of 6? That is 2500 plus the integral from 0 to 6 of this expression. And what do you get for y of 6? Okay, so how much sand is there at time t equals 6? Now what we're going to do is integrate 3t minus 2 plus 5 sine of 4 pi t over 20. Back to t from 0 to 6. Okay, and we get a total of 2493.28 cubic yards. Now we need to test 5.1179 because that is a critical point. So we do 2500 plus the integral from 0 to 5.1179. And just for space, I'll just write S of t minus R of t. Okay, and what do we get as a result of that? So 5.117. So it's trying to evaluate it, and what we get is 2492.37. So obviously, at time t equals 5.1179, we have an absolute minimum. Okay, and that minimum is 2492.37 cubic yards. Okay, and we're done. We just solved the FRQ from 2005. Thanks for watching.